Okay, so just to make sure that I am sufficiently torturing you, I have a little warm-up here. Now, if you skip some pages between Unit 0 and Unit 1, just a couple of pages, and I'm sorry, I should have told you this earlier, you might have already started Unit 1, maybe go to the back of your notebook or something. You can put in some problems that are review stuff from pre-calculus or Math 3. So maybe just put these right in there. So I want you to take a minute and do those. Okay, hopefully we recognize that they are all equal to 1. Okay, and Matt Callis, I did a major mess up in the video on the log function, so make sure to talk to somebody in the class about that. Okay, so this is a log property that we want to memorize. Oops, whoops, whoops, hold on a second. There's a problem here with number 4. Uh-oh, here's x, and x is -2. We said there's an asymptote there. X cannot be a number less than 0 or equal to 0. Infinitely close to 0, but not equal to 0. This is undefined. Okay, so be careful, because x cannot be a negative number right there. Okay, so the thing I want you to remember, all log functions, no matter what the base is, they look basically the same. And it's going to look like that. Okay, and I want you to note that that is the point 1, 0. The log of 0 is equal to 1. Okay, and the domain, all real numbers greater than 0. All right, so now let's look at this trig functions. Now we've went over the sine and the cosine, so you can go back and look in your notes on those guys. But let's look at the tangent function. Okay, so tangent, so just so that you see how I do this, I'm going to say that the tangent of theta is the sine over the cosine. So the thing I know about this is that the tangent is going to be undefined wherever the cosine is equal to 0. Okay, so there's going to be a bunch of asymptotes there. I don't always have those memorized. I have to think to myself, sine over cosine, where is the cosine equal to 0? And then I think about my handy dandy unit circle. Remember, this is the origin. The cosine is 1, 0, -1, 0, 1. Okay, you should be able to quickly go through that. So the cosine is 0 here and here. So at pi over 2 and 3 pi over 2. Well, we could keep on going. Around and around and around, backwards, backwards, backwards. So I'm going to say that it's undefined at pi over 2, 3 pi over 2, but I know it keeps on going, and I could do negative numbers as well. And so this is something we got to be, how do we say that? So sometimes people go, oh, well, you could just say multiples of pi over 2. Well, the problem with that is, let's say I had pi over 2 times 2, because that's a multiple. Well, that's pi, because those would cancel out. So no, at pi, the cosine is -1. It's not 0. Okay, let's say I did pi over 2 times 4. Well, that's 2 pi. Well, the cosine of 2 pi is 1, not 0. So it's not multiples of pi over 2, it's odd multiples of pi over 2. Okay, so cosine is undefined, at odd multiples of pi over 2. Okay, so when it's undefined, which means I'm dividing by 0, I'm going to have an asymptote there. Okay, so if I look here on my book at pi over 2, there's an asymptote, negative pi over 2, because that's a multiple of pi over 2. 3 pi over 2 and negative 3 pi over 2. Okay, that's about it. I know that the tangent is equal to 0 when the sine over the cosine is 0. So the tangent is equal to 0 whenever the sine is equal to 0. Sine is the y value. So the sine is 0 at 0 and at pi. Let's see, at 0 and at pi. And it's going to work that way. So that I figure out, and I then just have it memorized that the tangent function looks like this. And I don't worry about knowing any other points on that function. But I do know the general direction it goes. Now, when you do the cotangent graph is going to do the same thing. Its asymptotes are going to be in a separate spot, and it'll go this way. But I'm going to let you guys figure that out, just like I did the trig function. Okay, so tangent, the domain is not all real numbers. The domain we had a little problem with, and we said, well, it's not defined at odd multiples of pi over 2. So I'm going to say that the domain, wait, let me see if I wrote this in my other book. I want to write it the same way that I have been writing it. And no, I don't have my other little book here, so I'll just write it the way that we write it. Okay, so I'm going to say that it is all real numbers. Remember, double bar R, that's not a TR. It's all real numbers except odd multiples of pi over 2. Okay, the range, all real numbers. And the period, that's just when does the graph just start looking like itself all over again? Well, from negative pi over 2 to pi over 2. Okay, the length from here to here is pi. And then it starts doing its thing again. So the period is pi on this one. Okay, so that's all that I have memorized about the trig function, y equals the tangent of x. So I want you to do the cotangent, same exact way. Now, when I look at something like the secant and the cosecant, okay, so let's think of cosecant. That is 1 over sine. Okay, so I always have to think about that. And then what I do is I kind of make a little graph of the sine function. And I make sure, I got these in the right spots. No, I don't. So you can see even I have to double check what is the graph that we're working on. Okay, so I'm just going to make this dotted because it's not part of the graph. Okay, so this should go here, this should go here, here, and here. Okay. So I know that this graph is undefined whenever the sine is 0. Okay, sine is 0, that's the y value, there and there. So it's 0 at 0, and it's 0 at pi. So that tells me that there are asymptotes right there. And that is going to keep on happening. Okay, so asymptotes and these values. Okay, now I memorized nothing else except that the cosecant graph goes on the back of the sine graph. So I know it goes like that. It goes like that, and it does equal this value right there. It goes like that, and it goes like that. Okay, so that's it. So the domain is going to be all real numbers, except, here we go again, we're on odd multiples of, is it pi over 2? Let's see, 0, pi, 2 pi. Not odd multiples. Even multiples? Let me double check that. I gotta think about this. No, multiples, right? I'm sure you guys will let me know if I'm wrong. Except multiples of pi. That makes sense. Because every time I move pi around on this unit circle, which just means halfway, the sign will be 0. Okay, the range. This is a weird one because it never is going to go inside of here. So I'm going to say that it's all real numbers except for the numbers from -1 to 1. And maybe I should write this. I'm going to go like this. Oops. Because it can equal -1 and it can equal 1. So I shouldn't have, oh my gosh, it's Friday. Okay, so except those numbers. So it's everything out here except that. Now its period, it's going to have a period of 2 pi because this is 2 pi from here to here. And then it has to go 2 pi from there to there before it starts to look the same again. Okay, so that should help you get the secant graph and then use what you know about the tangent graph to help you get the cotangent graph. Alrighty, see you guys later.